interesting one on games and tournament, but it's on tennis. So I'll give you about a minute's time to go through, please review this question, right? So I'll give you about 90 seconds. So let me pause, right? And you guys do the reading. So are we almost there? So we need some more time. That's quite some data. And I'm yet to give you the questions, right? And we have the questions on the adjacent slide or the next slide. So these are the questions. It will take about 15 seconds or 20 seconds to read them. Just read the question. Don't worry about the answer options. That's fine. We'll review it. Right. So I think that's good enough for time. Let's do one thing. Let's take the question and let's look at attempting it. Okay. So let's do it together. Right. I feel this question is on the borderline, a slightly tricky one. What are the chances of questions coming like this in exam? Very highly if you look at CAT 2017, if that model is sought for this year, right? This could be a typical one of those caselets. Of course, for many of you, this will be the first time you'll be doing a question. But having said that, a little bit of idea about types of games and types of tournaments, right, is very good. So there are like two standard types in games, right? Apart from the standard types, there are a million other types of games, right? You could create your own game. But today, what we'll do is we'll look at the standard two type of games. What are the standard two types we're talking about? One that we call the round robin, right? The round robin. Second is the knockout, right? So when we are talking of a knockout, we simply are trying to say that at the end of a match, one team gets eliminated. That's when you call it a knockout, right? There are several games in which you can see knockout. Most of the combat sports, right? And some of the other sports like tennis, badminton, and table tennis, right? They will always almost be a knockout tournament, right? So that's what we're talking about knockout. Now, what's a round robin? What do we understand by a round robin? A round robin is one where the player will play every other player, right? A team or a player will play every other player exactly once. Now that's a kind of tournament that we call the round robin, right? For example, if there are four players, let's say there is A, B, C, and D, right? So in a round robin, what will happen is A will play with B, A will play with C, A will play with D, B will play with C, B will play with D, and then C will play with D, and that's it. D is already played with A, B, and C. That's a round robin. What happens in a knockout? Right? In a knockout, we don't know what's happening, but let's say A and B play a match and C and D play a match. The winner of this match will play with the winner of this match, right? Okay, so here you will see the number of matches. The number of matches in this case right, is given by NC2. We all understand what is NC2 or NCR, right? And that is n factorial divided by n minus r factorial into r factorial. We all understand that. And in a knockout tournament, you see the number of matches given is 3 here. So if I say, you might say, why this way? Why not A and B play a match, the winner plays with C and the winner plays with D? Very well. You'll notice that the number of matches is still 3. So why is it 3 in this knockout tournament, right? For we want a winner out of 4 players. To find a winner out of 4 players, it's pretty simple. You need to eliminate, right? It's damn simple that you need to eliminate the number of players. So you need to eliminate 3 players to find a winner out of 4. So for eliminating 1 player, you require 1 match. That's why to eliminate 3 players, for example, A and B, let's say A loses. You've eliminated 1 player. The match between B and C, let's say B loses. So we've eliminated 2nd player. The match between C and D, let's say C loses. So we eliminated the 3rd player, right? And D automatically will become the winner. So it simply is a count of the number of players that you're trying to eliminate. So that gives you an idea of this kind of tournament, right? That's called the knockout. So there's round robin and there is knockout, right? If that's good, right, we'll start, but this is not the only type. We'll do several other questions on games. We'll probably one of the sessions I'll do the matchstick game, right? And in other sessions we'll do several other variants, right? And today itself we did one game, right, or some kind of a competition where they were running in a competition. So the variations is quite large, right? Quite large in games and tournament, but predominantly if we are really talking of a little logical type, it would be based on these 2 cases, right? So let's start with the question now. So what we are going to do is we're going to read it together. You've already read it, so let's quickly review it, right? So this data will be given, so please read through all this. You guys will be knowing a little bit about the different games, like for example, tennis, cricket, hockey, badminton, or basketball, or volleyball. Some standard rules, knowing that may help. Though having said that, it's not necessary that the rules should be maintained in your actual examination. They might actually change the rules because many people might anticipate. So it's very important to go through the rules, but quickly. If you know the rules already, you might not spend time, right, to understand the rules, and that could be easy. But if you know if the rules are different, then yes, it will definitely take some time to understand, right? So let's do one thing. Let's start. Okay. So there is 128 players, and we're talking about knockout tournament, right? So we are definitely talking of 127 matches. So wherein there will be a round 1, there will be 64 matches. Round 2, there will be 32 matches. Round 3, there will be 16 matches. Round 4, there will be 8 matches. Then the round 5 becomes a quarter final. There will be 4 matches. The round 6, that will become the semi-final, right? There will be 2 matches, so one winner and one winner. They'll all go to the final. There will be 1 match, and the winner is declared, right? So this is exactly what should be happening. Normally, in a regular knockout tournament, you don't have to worry about the rank 3. We normally don't worry about the rank 3, but that's okay. Sometimes they might have another match for a rank 3, but this is generally how the matches should be done. For 128 players, it could be tennis, it could be some other game as well, or some other sport. So let's look. The tournament was played on a knockout basis. Each match played in this tournament is the best of 5 sets. Each player is declared a winner as soon as he wins 3 sets. The match is not played for 5 sets if he wins 3 out of the first 3 or 3 out of the first 4. That means if you get a 3-0, you won the first set, you won the second set, you won the third set out of 5 sets, you become the winner. But if you won out of 4, any 3, and for example, you won out of the 4, 1, 2, 3 and 4, you definitely won the 4th set, right? And in between 1, 2 and 3, right, you have definitely lost 1 set, right? You definitely have won the 4th set and definitely have lost exactly 1 set in between. You could have lost here, or you could have lost here, or you could have lost here, right? That means you won 1, 1, you won 1 and 1, or you won 1 and 1. And these could be the three possibilities in which you could, end up winning the match with a 3-1, right? Likewise, a 3-2, that means we have 5 sets. This last match, fifth set, should be a winner, and then we can have multiple conditions. Again, we can have multiple. That means 2 wins and 2 losses. There will be several cases. It will be difficult for me to draw, right? So it's just that 2 of the cases here will be win. For example, a win-win, loss-loss, and a win, or a win-loss, win-loss, and a win. But you can only win twice and only lose twice in this set, right? So that's what it is, right? So you can win a 3-0, you can win a 3-1, or you can win a 3-2. The match. If the player wins a match without losing a set, it's called, right, a straight set victory. Right? There's certain terminology. Anyone who follows tennis would know this. Given below is a performance of the Indian Open by 5 players who participated. There are 128 players, but out of the 5, probably the top 5 players, Hewitt, Roddick, Federer, Agassi, and Henman, right? They are the 5 top performers in this. A player wins a set as soon as he wins 6 games. Now, within a set, you have something called a game, right? Whereas the game score in a set between 2 players is tied at 5-5, then the number of games required to win a set increases, right, to 7, which cannot be further increased. So if the score is tied at 6-6, then the player who wins the game is declared the winner. So what happens normally in a game, right? So in a game, you have to lead the other people by minimum 2. That means you can win a game 6-4, you can win a game 6-3, you can win a game 6-2, you can win a game 6-1, you can win a game 6-0. You cannot win a game 6-5. However, assuming that it is a 5-5, right? Then what happens is the minimum difference should be 2 in a game, right? So you start playing and you assume that you will hit a 7-5. But then what happens is there's a situation called a tie break in which you end up with a 6-6. So you end up playing a tie break. That means you don't try to play this match and you don't try to make it an 8-6. It's not going to work. Instead, they're just going to play the tie break. Whoever wins the tie break will be the winner. That means the winner will become a 7-6. Alright? That's your game scores of winning. Right? That's how it happens in tennis. Right? There's certain standard rules in tennis. So let's look at the question. What can be the minimum number of matches in which Agassi achieved straight set victory? If Roddick won the semi-final against a semi-final, then against whom? And the runner-up of the Indian Open won his semi-final match with a score of what? What can be the maximum number of games won the player in the Indian Open tennis tournament? So let's take the first question. What can be the maximum number of matches won by in which Agassi achieved straight set victory? Maximum number of matches. So let's quickly write down. This is your round 1, round 2, round 3, right? Round 4, round 5, and so on. So let me do it right here. We have this data, right below the data also we could do it. Let's do it that way. It will make more sense. So round 1, round 2, round 3, round 4, round 5, right? So that after this itself will become the quarterfinal, semi-final, and final, right? So this is your round. Okay, so for each person we'll just map what's happening, right? So Hewitt, Hewitt is scored a total of 17 sets won and lost a total of 8 sets, right? If you have to win, you have to win a 3-0, a 3-1, or a 3-2. That means definitely in the first match or the first round, Hewitt is 1. In the second round, Hewitt is 1. Third round, Hewitt is 1. Fourth round, Hewitt is 1. Fifth round, Hewitt is 1. That makes it a total. So what are we talking about? A total of, right? A total of how much? We are talking of a total, right? A total of 15 already. So we have 2 more. We have 17, right? So we'll make it 2, right? Give me a second. Let me just erase that part and call it the quarterfinal and final, right? So that's your semi-final and that's your final. So which means here, this is where Hewitt loses, right? This is where Hewitt loses. So Hewitt would have lost, right? Definitely you lose. You got 2 points. The other team has to win. So the other team will get 3 sets, right? So the rest of the sets here, that means this could be a 3 something, 3 something, 3 something, 3 something, 3 something. The something could be 0, 1 and 2, but the total of these somethings, right, including this 3 would be equal to 8. Right? Let's look at Roddick. Roddick has won a total of 21 sets. That means this is a 3 something, we have 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 a 3 something, that is about 18, and then it is reaching the final as well. But look at the sets lost. There is 14. Right now, how do we distribute 14 among 7? Can we put a 1, 1, 1 kind of thing? No, the only possibility that I or you or anybody could think of, right, is placing the 2 and 2 and 2 and 2 and 2 and 2 and 2. Right, that's for Roddick. Let's look at Federer, right? Okay, so we are doing this though the question is an Agassi, right? Okay, but then we are just trying to review this question. Okay, so Federer is only 10, so that is 3 something, a 3 something, a 3, that's 9, and this match that is lost. That means 1-3 you're going to lose, right? And Federer is also won 10 sets but lost 8 sets. Out of the 8 sets lost, 3 sets are lost here. That means in these 3 sets a total of 5. That means there could be a 3-2, 3-2 and a 3-1, whichever order. We are not sure of the order, right? If you look at Agassi, right? If you look at Agassi, right? Agassi has won a total of 16. That means 3 something, 3 something, a 3 something, a 3 something. Round 4 over. Round 5 by the round 5 you would have finished 15 sets, but here it is 16 sets won. By winning also you can lose the match, right? To 1-1, and the other side should have won the other 3. That means there are left over out of the 6 sets lost. Out of the 6 sets lost, we are talking of 3 accommodated. That means these matches could be anything. And last, let's look at Henman. Though the question is on Agassi, let's quickly review of Henman, right? If you're talking of Tin Henman, right? So we are talking of a 3 something, a 3 something, right? And a 3 something and a 3 something, that makes it 12, but we are talking of 13 here, right? You can look at the graph. So that means 12 plus 1, that will give us 13. This match would have been lost 3, right? But the total number of matches lost would be, total number of sets lost is 4. So between these 4 matches, right, among these 4 matches, many of them would be 0, and one match would be a 1. So one of the matches Henman won 3-1, and right, rest of the matches would be straight set 3-0, 3-0, 3-0, and the last match Henman lost 1-3. Okay, so while we're doing this question, let me also see. Let's understand that Roddick is definitely played in the final, because Roddick has gone to the final, and the final score was 3-2. That means someone is lost, right? So let's call that person as a Mr. X. Who's that X? We don't know, right? Mr. X has lost the final with a score of 2-3. That's for certain. And the other matches, that means round 1, round 2, round 3, round 4, round 5, and round 6, this person would have, this person would have definitely won a 3 something, a 3 something, a 3 something, a 3 something, and a 3 something, right? But you look at this, okay? It's for sure that Hewitt went to the semi-final. Hewitt, the last round, Hewitt went to semi-final, and the result is lost. Roddick went to the final, and the result is 1. Roger Federer was lost in the 4th round, right? If you look at Andre Agassi, right? Andre Agassi has won 5 continuous matches, and the 6th one he lost. It's a knockout, so you have to continuously win. That means Andre Agassi has reached semi-final and again lost. And Henman is lost out in the quarterfinal. So we know definitely Roddick was also a semi-finalist. That's how Roddick has gone to the final, right? And if you look at Hewitt and Andre Agassi, they were both semi-finalists as well. But when they're playing together, let's just check, right? Who are playing together and who are not playing together, right? If you look at the semi-final score, if you look at the semi-final score of Hewitt and the semi-final score of Roddick, Roddick won at 3-2 while Hewitt lost it 2-3, right? Which could give you some idea that the semi-final match, there is semi-final 1 to be played between Andy Roddick and Hewitt. and Andy Roddick won a 3-2. Why do I say so? Why can't it be, Andy Roddick won with, the Mr. X? You cannot win with Mr. X and still make Mr. X go to the final, right? Which automatically means the semi-final 2, right, has to be between Mr. X, whoever that X is, and Agassi. And the match result was 3-1. Agassi lost with just one set and Mr. X won 3 sets, right? Which also means in the semi-final match, Mr. X won 3-1, right? Are we okay with the semi-final score? So this is a 3-1, this is a 2-3, this is a 3-2, and this is a 1-3. So, Hewitt and Roddick played a match, and Mr. X and Agassi played the semi-final match, and we know the winners here. So now let's look at the question 1. What can be the minimum number of matches in which Agassi achieved straight set victory? Minimum number of matches. See, please understand minimum number of matches for Agassi. If you want minimum number of matches in which you get straight set, we will try to assign. Total number of sets lost by Agassi was 6. Out of the 6, we have already accommodated these 3. Right? We have already placed this 3 right here. We place this 3 right here where the tick is. Right? So we got to place the others. We got to place the other 3. Right? We got to place the other 3. Where do we place them? Where do we place them? So we want to decrease the number of straight sets. So we'll try to put a 1. We'll try to put a 1. We'll try to put a 1, right? That means this could be a 0 and this could be a 0. The minimum number could be 2. Can it be more than 2? Of course, why not? We can try to make this 2. We can try to make this 1. Then there could be a 3 set. 3 times this person got a straight set with you. But we are not looking at maximizing the number. We are looking at minimizing the number. So the answer is pretty simple. That will be 2 times. Now, this information is pretty important. We are going to use it for the next question as well. You look why. If Roddick won the semi-final match, then against whom? We've already done that detailing. If Roddick won the semi-final match, we saw that Roddick won the semi-final match, and Andy Roddick won a semi-final match with Hewitt. Right? That's pretty simple data with Hewitt. And if you take the next question, the runner-up of the Indian Open won his semi-final match with a score of. So the runner-up. So what is the runner-up scored here? Right? The runner-up is Mr. X because Mr. X lost in the final. Mr. X. So this is the final, right? Who played? We have Andy Roddick played with Mr. X. That can be the only thing because both of them are finalists, right? So this is 3, that is 2. So in the final, the question being in the final, if you're talking of in the final, the runner-up of the Indian Open won a semi-final match with a score of what? But in the final, we know he's gone. So runner-up is definitely the runner-up. The runner-up won his semi-final match in the final. The runner-up won a semi-final match with a score of 3-1. Right? And this person is played definitely with Ante Agassi that we've given here. Right? So in the semi-final, won with a score of 3-1. That is Mr. X. The runner-up here in question is Mr. X. Let's look at the question number 4. And now this is a good question. What can be the maximum number of games won by any player in the Indian Open tennis tournament? See, we understand what is a game, right? You got to win like 6-4 or 6-3 or 6-2 or 6-1 or 6-0 and so on. Now it's but obvious. The person who plays the maximum number of sets, the person who plays the maximum number of sets will be the first contender to hit the maximum number of games. And if you look by default, there is nobody who can play more number of sets than Roddick. Roddick is won while winning. He's won 21 sets. While losing, he's won 14. That makes it 35 sets. But if you look at Mr. X can never reach that value. Mr. X, if you look at the previous table that we have drawn, Mr. X, even if he plays a 2, 2, 2, 2 and 2, right, even if he plays these values, the total, right, for winning will only be the total for winning and losing. That means the number of sets won and lost together for winning would be a total of, while winning 19, while winning that would be 20, right? while winning that could be the number 20, and while losing they're talking of 14, right? Max, that's the maximum limit. We don't even know if this happened. So that makes it only 34. But if you look at our question number, 4, the maximum we found is 35. So this person can definitely win the maximum number of games. So when Andy Roddick won 21 times, each of the 21 times, let's assume he won either a 7-5 or he won a 7-6. That means the number of games won is 21 into 7, which is 147. Right? That's quite a number, right? Instead of making him play a 6-0 or a 6-1 or a 6-2, let's play him a 7-5 or a 7-6 and make him win more number of games. However, while losing, he lost 14 times. He lost 14 sets, right? He lost. But each of the time he lost, he could actually win some games, right? And the best way to win game and still lose would be a 6-7 because we want to maximize, right? After a tiebreaker, I told you it could be a 6-7. So this could be the number of times he won sets despite losing the set, right? So we are talking of 14 into 6, that's equal to 84, and the total number of sets will be this while winning and this while losing. So 147 plus 84, that gives us a number 231. So this is the max possibility that the person could actually do, right? So that's a good question, right? Are we good, right? Are we okay? I still get up. Can we do another question here? Right? Shall we try that? Okay, so let's do this pretty quickly. Let me also review this question. Let's quickly review this question. So what is the case about? See, and would you be choosing a case rate like this? See, the question is that this has a lot of data, right? This part has a lot of data to understand, right? But the data is pretty simple. Look at the graph. The graph is very simplistic. They've given the lines which clearly gives you visibly the graph is not too difficult, right? It's you have your horizontal or your column chart, right? It's very easy data that we have, right? Though it's on games, but it's a simple game, and like I said, this is a must attempt in a question like cat or z. If a question like this comes, it's a very simple one. Data is clear. It's not too decisive kind of thing, right? Or indecisive kind of thing, right? It's a simple data, right? There's no too much jargon, right? They're not really talking. There's a little bit of straight set victory, but they've explained it well, right? So this is a must attempt in a paper like CAT, right? You'll notice in CAT 2005 there was a question on tennis. Probably we'll pick that in another session, but okay, so it's very simple. Even the questions were easy. You notice once you draw this, once you make closure of this particular table, you're more or less done with the entire question, right? Okay, so good attempt, worthwhile. Simple questions. This one will take some time and calculation and a little more logical than the other question, but however, it's an easy one in any case, right? So we'll go to the next case. Shall we? Yeah. Shall we go to the next case? Let's try another one, right? Let's see what we're talking about. Simple one. Okay, so I'll give you probably a gambling game, right? And let's take maybe about 60 seconds to read it, and then we'll do it. Okay, so that pretty much finishes the time. So I think that's an interesting one, right? That's an interesting one, and plus I've not given answer options, so that might be something very striking, but it's a thing that we'd like to work with. Let's see what we're trying to do here, right? Any guesses on what's the answer? You guys would like to post on what's the answer? Something, right? Let's see. There is four guys are gambling in this. Different people lose in different games in reverse alphabetical order, right? In reverse alphabetical order, they lose. So the first person to lose would be D. The second person to lose would be C. The third person to lose would be B. And the last person to lose would be A. That's the reverse alphabetical order, right? So this is how they'll be losing. A would be the first person. It would be winning, right? In three out of the four rounds, it would be winning three rounds, right? The first person to lose would be D, right? And this is what they're talking, right? So that's some data. The rule is that if one loses, he or she should double the amount of others, okay, from what they were holding at the beginning of that game, right? Assuming that, if you're talking of A was holding 1, B was holding 1, C was holding 1, and D was holding, let's say, maybe 13 or something, right? So then E would double what A has at the end of the round. That means A would become 2, B would become 2, C would become 2, and D would automatically become 10, right? But this process continues. I'm not saying these are the values we should be looking at, but at the end of the fourth round, each of them had 32 rupees. So we know what's happening at the end of the fourth round. Okay, we have no clarity on what's happening right before that. Okay, so let's look at this. So we have let's draw it this way. We have a round one, we have a round two, there's a round three, and there's a round four. It's not that you have to map it in the reverse order. You can do it in any order, right? That's really up to you. And we're talking of the winners, the people losing or winning. That is A, B, C, and D, right? At the end of the round 4, everyone, right? At the end of the round 4, right? So everyone has 32. So A has 32 rupees, right? B has, 32, C has 32, and D has 32. That's the end result, right? Now, if you're trying to map, right, see what happened in the round 1, right? What happened in the round 1, you will now try to see what is happening before. I mean, we have absolutely no idea what happened in the round 1, right? But we know end of round 4, this is the result. But who lost in the round 4? The person who lost in the round 4 was A, right? But B in the round 4, after the round 4, B's got 32, C's got 32, D's got 32, which means A is doubled. A is taken his, some number of, amount, and he doubled this, he doubled this, he doubled this, right? Which means what? Which means the amount, which simply means the amount that B had at the start of this round was 16, C had 16, D had 16. While A should have contributed this, you'll also notice that this total is 128. This is just redistribution of wealth. This total also should be 128. Either you can take 32 plus 16, 16, 16 because contributed 16, right? 32 plus 48, right? We can do it that way. 32 plus 48, that would be 80. Or we can take the total 16 plus 16 plus 16 is 48. We need a total of 128. So we can write it as, 128 minus 48, that would give us 80. Whichever way you do it, right? That's happened in the round 3. The end of round 3, that means start of round 4, this is what has happened. In round 3, what happened, right? Now in this round, A is the loser, right? I'll put it in a box. A is the loser. In the previous round, I mean the round 3, B would be the loser. So we'll figure that out. But A's amount would have doubled. That means it was 40 certainly. It is doubled to 80. And C would have doubled. That means 8 would have become 16. And D would have doubled. That means 8 would have become 16. Which automatically implies, right? And we have 48 plus 8 plus 8, that is 56. We have 128 minus 56, right? That would be the amount, right? That we are talking is the amount that B had, which is 72. Or we can simply say 16 contributed 8 here, contributed 8 here. That makes it 32, and 40 contributed to 8. Whichever way you guys are thinking. In the round 2, the person who lost is C, while in the round 1, the person who lost is D. Let's look at round 3. Round 3, from round 2 to round 3, right? This 40 that we have for A, previous round should have been 20, right? This 72 should have been 36, this 8 should have been 4, right? Now someone has contributed to all this, right? So the score by C, right? The score by C would have been 128 minus the total of these two, that's equal to 60. That means we're talking of 68, right? We're talking of 68 that C had, right? And C is the second loser, I mean the second round, right? In the last round, A, B, and C all have got some points from D because D is lost. So A would have been 10 at the start, B would have been 18 at the start, C would have been 34. We're talking of 128 minus 128 minus 62, that would give us a total of 66. That means, in the first round B had 66, he's doubled the rest of the scores, right? And then A became 20, B became double of 18, that is 36, and C became double of 34, that is 68, and D from 66 fell down to 4, and likewise it went up and up and up, and we have the fourth round, 4 rounds. So the question, pretty simple, right? If we are looking at a question like this, right, they might ask questions like, what they've just asked one question: what is the sum total of the money will be at the end of first round? Right, at the end of first round, D had 4. At the end of second round, E had 3. At the end, E had C had 8. At the end of third round, A B had at the end of third round 16, and A had at the end of fourth round, that would be like a 32. Right, so we just got to add that. That is a simple calculation, right? We don't have to break our head on too much on this kind of calculation, right? We look at a total of 60 here, right? That's pretty simple data for us to work with, right? So we good? This kind of question, right? Pretty different kind of case rate here again, right? There's also a kind of game. So we cannot call it a round robin. We cannot call it what do you say, a knockout. It's slightly different, right? That's what I'm trying to say. CAT is about creating these things, right? And the idea, it's not that you need to really have solved a caselet like this before or the previous two to have known what should be the agenda or what should be the method by which we should be tracking such questions, right? So that's exactly what we are discussing, right? That's exactly what we are discussing, right? Uh, let's see, let's see. Okay, so good. Let's go to the next one, right? Are we all good, right? Can we quickly have a yes or a okay, right? So that we can move to another one, right? Mm-hmm. Good. So this question, I hope you guys have read it again. Just I give you some few seconds to review it. We'll move to the next question. Right. So that's some kind of a question. It has averages and it has a lot of other things. So let's quickly, you guys quickly read it. I'll give you about about 60 seconds. You don't need more than that time because the case sheet is very easy and we have a lot of questions though. I've put in a lot of questions.
Press the bell icon on the YouTube app and never miss another update.
Okay, so that's a minute. Simple one. Let's do this. Let's read it together once and then we can start with this question. Okay, so what's it we're talking? What's it we're talking about? We're talking about a soccer season. Every player had scored a prime number of goals. Okay, that's interesting, right? A prime number of goals, and the average of 11 players is right. Uh, was the average of the 11 players is total was also a prime number. No player's individual tally was the same as anyone else's or as the average, and nobody scored more than 45 goals. Right? So nice question. It's trying to integrate prime numbers with something that we can think of, right? That's average. So we're talking of an LRDI, where very simple LRDI. We're talking of prime, we're talking of averages and distinct primes, of course, right? So let's look at the question this way. Now, quickly, if you're talking of between, prime numbers from 1 to, 45. Now, we all understand what is prime, right? We all understand what a primes, right? Prime numbers. These numbers have exactly two factors, right? And what are factors? Factors are numbers which completely divide another number, right? For example, 1 is not a prime because it has only one factor. 2 is a prime because it has two factors, 1 and 2. It can be completely divided with 1 and 2. That means if there are two marbles, I can keep it as one part together, or I can divide it into two parts, right? So that's a prime number, right? While a number like 4, right, we can divide it into one part, two part, or four parts, right? So not a prime, right? This is a prime. 3 is a prime number, 1 and 3, and so on. So we understand what a prime number is, right? Alright, so what are the prime numbers from 1 to 45? Right? If we're talking of a prime number, we're talking of a prime number from 1 to 45. Right? So what are the numbers? We're talking of 2, we're talking of 3, 5, 7, we're talking of 11, 13, 17, 19, 23, 29, 31, 37, 41, 42. We stop here, though 47 is a prime number, but it's reaching our limit. That is, we are talking of 45. So how many numbers do we have? We have a total of 15 numbers, right? We have a total of 15 numbers, right? Okay, we have a total of 15 numbers, right? Nobody scored more than 45 goals. No player's individual tally was the same as anyone else's or of the average, right? There are like 15 things, out of which 11 of the players will have some score or the other here, right? 11 of the players. And one more number. That means there are going to be 12 numbers that we're going to have right here out of this, right? Out of this total set, sorry, I said 15, out of this total set of 14 numbers, right? Two numbers are going to get cancelled and two numbers are going to, 12 numbers are going to remain. And one of the 12 numbers is actually the average, right? One of the 12 numbers will be the average of this entire set, right? First question, what is the average of their goals scored? What is the max? Then they ask what is the maximum number of goals scored by a player? What is the minimum number of goals scored by a particular player? Now, if we add all of it, let's do a simple addition here, okay? So we are talking of 2, 3, 5, that is 10. We have 7 plus 13, that's another 20, so that makes it 30. We have 17 plus 23, that is 40. 30 plus 40, that will be 70. We have a 19 plus 11, that will be another 30. So 70 plus 30 is 100. We have a 29 plus 31, that is 60. So we have 160. We have a 37 plus 43, that is 80. So we have 160 plus 80, which is 240, plus we have a 41, right? That means 240 plus 41, the total is 281. Now I am assuming that you guys will be fast at calculating this, right? I would suggest don't use a calculator, on-screen calculator, because in on-screen calculator you're not going to actually type the values. You're not allowed to use a keyboard. All you will be using is a mouse, and with that mouse you'll have to strike on the given buttons, right? So you've got to be a little careful there, right? So that's something. Okay, now there are 12 of these numbers. 12 of these numbers you have to choose, right? If I divide this total score by 12, we know average is, we know the formula for average. We know the formula for average. Average is sum of quantity or sum of observations divided by number of quantities or number of observations or number of values, right? So if we're looking at this number 281 by 12, what number are we talking about, right? 281 by 12, that happens to be 23 point something, or let's take it this way, 23.5 by 12. Now 23 is a prime number, but this particular part, this particular part, that is 5, is something that we cannot maintain, right? We cannot maintain this 5, right? So this 5 has to be removed, then automatically we'll have the average of 23. That means we could take 281 minus 5, we'll end up getting 276. Now this, if we divide by 12, this average will become 23, right? So what does it mean, right? It does it mean the average of this goal scored is, let's say the average of this goal scored is 23. Well, not yet, not yet. All right, why not yet? Because we could also think of a smaller number, right? We have the average is 23. Probably we could remove two more numbers, and why not think of an average of, let's say, below 23, right? And let's say, see, right now why I'm saying below 23, because we have only removed 5. To remove 5 we can only remove 2 and 3. As of now we know this, right? But what if we have another case? So let's put it in another slide. So I have the same data, right? So we are looking at these numbers, that is 2, or let me write it here, 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, right? We have these 14 numbers. Now, can we make the average as 19, right? We want to make the average as 19 because below 23 we have to now decrease. That means we're going to take out some bigger numbers, right? So 19 is the average, but we know average is equal to sum of quantity divided by number of quantity. We know average is equal to sum divided by number. If we are talking of the sum, the summation should be, right, the sum of quantity should be average into number, right? So we are talking of average, and how many quantities are we talking? 12. That includes the term as well, right? So 19 into 12, what are we discussing? 19 into 12, right? What's the number that we got to discount, right? So we're talking of 19 into 12, that is 228. But what is the total score that total of all these values? That is 281. The total of all these values is 281. Why are we discussing this? If I take 281 minus 228, the difference happens to be some number. And what number are we talking about? We're talking of the number 53. Now, why is this number important? Well, if I take if I ignore the 2, right, we need the sum of two numbers to be an odd number. All the numbers are odd except 2. So that means 2 has to be there plus. If I take any number, can the summation of these numbers be 53? We cannot take any number, right, and the summation being 53. Even if we take 43, that's the highest, the summation would only be 45, right? We need to place it 2. We cannot take 43 plus some number and make it 53, because sum of two odd numbers, odd plus odd, will give us even, but this number in context is odd, so we cannot fetch this result. In fact, if 19 is not possible, do you think 17 is ever possible? That would be a much lower range for us, right? With 204 from 281, we'll have to discount a much larger value, and we're going bad, right? We're going worse and worse. That will just not hold true. That will not hold any ground for us, right? That means we come back and we have understood that the average, irrespective of what happens, right, will be 23. And if the average is 23, the total has to be 276. That means we have to discount 5 of two numbers. You have to discount 5. One number you have to remove is 2. One number you have to remove is 3. That can answer some question. What is the average of the goals scored? The average of the goals scored is equal to 23. Second question. So this is a short answer type question. What is the maximum number of goals scored by a player? That of course is 43. What is the minimum number of goals scored by a player? That would be 5. So pretty interesting, right? Now let's go to the second part of the question, right? With the initial information, if now we realize that nobody scored more than 50, right? Nobody scored more than 50. Yeah, one more thing that you guys might have thought. What about the numbers? We have this. So what is the average? Average is obviously 23. You can check the total. We know that from the average, that means from the total 276, if we reduce 23, that means we're getting 253. This, if we divide by 11, will also get us the same average. So nothing to worry. That's the reason we could easily discount that number, right? Then the question 4 is slightly different, right? With the initial information, if now we realize that nobody scored more than 50 goals, right? That means 11 players together, right? Nobody scored more than 50. So we have 2, 3, we have 5, 7, 11, 13, 17, 19, 23, 29, and like we did in the previous case, right? We're just writing down the prime numbers, right? And the last prime number in question is 47. So we have added one prime number, unlike the previous case, we have added another prime number, right? We've added another prime number. No player's individual tally was the same as anyone else's or as the average, and the average is more than 15. How many possible average scores can we have, right? Now, how many possible average scores can we have? Let's do first. Let's tally the total, right? Like we did in the last question. We're going to first look at the total, right? And we need 11 players and one more, that will be the average, that has to be distinct. If we take the total, right, till sometime back we had calculated, that is 281. Now, if we add that excess of 47, if we add that extra number, that is 47, we will get the total, right, of 300 and 328, right? So we're taking 281 and adding 47. That gave us a total 328. But we got to divide it among 12 bits. Why 12 bits? For the simple reason, we assume there are 11 players and one person is going to be the average, which is again a prime number. So if we divide 328 with 12, we'll get an average of 27 4 by 12. So I've written it as 4 by 12 instead of 1 by 3 because this value should be discounted. But this question is 27, by the by, is 27 actually a prime number? No, so we cannot discount 4 from 328 and say, hey, listen, you know what? 328 and plus, you cannot discount 4, right? You cannot discount 4 because we have 3 numbers now that you have to remove. The total is 15 numbers here. It's no more 14 numbers. So we have to remove 3 numbers, right? And the summation of 3 numbers, you cannot put, minimum is 235. That's going to be 10. So we cannot work on this anymore. That means we got to come back the average if it is not right 27, right, if it is not 27, right, it cannot go higher than 27, right, it has to go lower than 27. It could well be 23. If it has to be 23, we know the total has to be 276, right, it has to be 276, right, that's one possibility, right, 276, right, divided by 12, that will be 23. 276 divided by 12, that's equal to 23. But we come back to the next part of the question, right? Can we have the average as 19, right? Can we have the average of 19? And we had noticed in the previous question, right, to have an average of 19, we need to make the total as 200. We need to make the total as 228, right? Because 228 by 12 is equal to 90. Now, is this a possibility, right? Is this a possibility? That means from 328, you have to discount 100, right? So that's not possible. So how many possible average scores can we have? The answer would simply become 1. The only possibility would be 23, right? Even after solving all this, we get only one answer. That's so cute, right? Okay, let's look at the question 5, A and B. In the question 4, what is the sum of the 3 values which is not the average? So what are the 3 values which is not the average, right? So obviously the values we need to take the total as what? 276 has to be the total, right? That means the sum of the other 3 numbers should be 328. So let me just quickly rewrite the question. 276, we have the other total as 328. That means the difference, right, should have been, like what? We're talking of a 50, we're talking of a 52, right? And we need to make a total of 52 with 3 numbers. Please remember 3 numbers here, okay? Let me quickly, okay, let's not even write. Let's talk about the 3 numbers that we are looking at. What are the 3 numbers that you have to discount, right? We need to discount a total of 52, guys, right? So how can we discount 52, right? But what are they asking? In what is the sum of the 3 values which is not the average? You have to discount 52. That's it. In question 4, how many values are surely part of the goal scored among all the prime numbers up to 50? Yes, surely. Okay, surely. So this is where we'll need some data. So we'll take 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47. So how many of them are surely, right? The question is, how many of them are surely part of the goal scored? We know 23 is definitely not part of the goal scored because 23 is the average. The total of the other 3 numbers which is not part of the goal scored is 52. You can have 2 plus 3 plus 47 giving us 52. But the question is this the only way we can present a 52? We must understand that 2 will definitely be one of the numbers, right? Why 2 has to be one of the numbers? Because the sum of the other 2 numbers can be made even. We cannot take 3 odd prime numbers and make the odd plus odd plus odd will give us odd, not even. So that means one of them has to be an even number to make the answer even. Why are we talking even? because the difference has to be 52. So this even number in question has to be 2. The other two odd numbers is what we are trying to figure out. So we have the sum of the other two numbers. This odd plus this odd should be, only this part that I'm talking, this odd plus this odd has to be equal to 50, right? So what all cases can we have? We can have, right, the first case. We already had the first case, right? We wrote 3 plus 42 is equal to 50. That's like case number 1. 3 plus 47 is equal to 50. But can we also have, right? Can we also have the next case, right? Can we also have another case and say, hey, we need a total of 50, but we could place a 43 plus 7, that's also equal to 50, and in any case 2 will be included here, 2 will be included here, so that will be added later, right? The three numbers has to be discounted. Next, can we try any other possibility? Of course, we can try 37 plus 13, that's equal to 50 plus a 2, right? That will give us a 52 in this case. So we have a total of 52, we have a total of 52, we have a total of 52. That has to be discounted, right? Can we also try something else like a 31 plus 19, right? That's equal to 50 plus 2, that will give us a 52. So in all these cases, right, we have a 52. And can we have something lesser than that? Okay, for example, a 29 or something? No, right? So what are the values that we have touched now? We have touched 47. That means it may not necessarily be, it's not surely, not necessarily the part of the numbers which will never be taken, right? It can be taken because we can remove 47. 47 plus 3. We could remove, 43. We could remove, 37. And we could remove, 31. What about 19? Yes, we had to remove that at one stage. At 13, we had to remove that at one stage, right? We had to remove the number, right? 3 at some stage, right? We could remove the number 2 because the first case that we had done is 2 plus 3 plus 47, right? These are all the possibilities that we have removed, right? 1, 2, 3, 4, 5, 6, 7, 8. There are 4 cases exactly, right? There are 4 cases exactly here, right? And so we had to remove 2, and apart from 2, we could remove 3, we could remove uh, 7, we could remove a 13, we could remove 19, we could remove 31, 37, 43, or 47. That means 9 numbers can be removed, right? 23 anyway not included. So out of 15, we can remove 9 and we can remove 1, which is the average, that is 23. That means only 5 numbers which are surely always part of the average or the goal score, namely 5, 11, 17, 29 and 41. Irrespective of what happens, these 5 numbers will necessarily be part of the run score in this question, right? Let's look at the question, other two parts. In the question 4, how many values are surely not part of the goal scored among all the prime numbers up to 50? So surely not, right? So you notice there's only one thing which is surely not, which is the number 2. Everywhere we have a 2. Here we have a 2, here we have a 2, here we have a 2, and here we have a 2. Only one number is surely not part of the goal score, right? And in the question 4, what is definitely not the least number of goal score? Definitely not the least number of goals scored. They should have given answer options here. Definitely not the least number of goals scored. So 3 is definitely, assuming answer options were 3, 5, 7 and 11, right? The least number of goals scored is definitely not 11 or something, right? Least number of goals scored could be 5, or least number of goals scored could be 11 or something, depending on the condition to condition. So they would give you 5, 11, 7, 3 or something, right? Depending on the question, right? So that makes it set. Makes sense, all of you, right? Pretty simple, right? Pretty weird as well, but they've taken a simple concept. Just look at the thing. A two-line question. A two-line question can be pretty interesting and intriguing in a sense. A little bit of mathematics involved and a question on goals, right? Like I said, yeah, anything can come in games and tournaments, right? So that's it for now, right? I think that's a good amount of working. So thank you for spending your time, right? And you all have a good day, right? And remember, last few days for cat, right? Focus on your building your mind. You know, on the last day, what you can perform is way, way, way more than what you can even think your potential is. So always be on a positive note. In the last few days, make sure you're talking to the right people. Watch, whenever you want to de-stress yourself, watch a little motivation videos. By motivation videos, I'm really not talking of movies. I'm talking of those 10-15 minute videos that you can watch in, online, probably on YouTube or somewhere, right? And that's it. And if you need beyond that any motivation, do a little bit of activity. Go for a 10-minute walk, right? And if you're feeling too sleepy, just hold the book in your hand or hold the tab in your hand and start walking around in your room every time you feel otherwise, right? So that's it for today. Thank you very much, and happy learning to all you guys, right?
You can learn any subject, anywhere, any place, and on the go. Come, let us go the other way in learning. Download our Revolution